The second submodule of the GSM drive test tool and optimization, that is we will discuss in this submodule, is the drive test parameter and different drive test tools that we are using in the BSNL for optimization of the mobile network. So GSM RF drive test parameter. So how actually we connect the drive test tool? It requires one laptop, right, and handset and software. Actually, our software is required, whether it is TEMS software or Nemo software. Other than this software in the laptop, one handset that should be connected to the laptop via USB cable, and one GPS. This types of GPS is connected with the laptop, and this one is the dongle software license required for whether it is a physical or nowadays server or login, direct device login is there. The no physical key, license key is required, but in the older version this physical license key is required for opening or taking the drive test, right? And this second one is the vehicle, and third one is the charger. Laptop charger is required for doing a long drive test. Okay, full day drive test. That for which charger required. Okay, how we will connect? We first connect the dongle with the previous version and then open our TEMS. After opening the TEMS, then we attach the mobile handset, attach the GPS, then attach or we can say add the drive test route and maps, right? Then we will load the update cell file. Update cell file means it is a cells, any operator, BSNL or any other operator that is having the information of their BTS, their cell, their CGI, their frequency, right? There is a specific format of that cell file. That cell file should be uploaded on the tools, drive test tool, so that it will visual all the cells on the map. And last, we connect all, just like in this TEM 16.1 version. You can see the phone is connected and your GPS, NEMEA, that is a GPS is connected. And after connecting all these things, you just connect all the devices and it is showing a green spot on the map. And when you add the cell file and all the files, the cell is also showing on the map. Cell will be also showing. Now some of the GSM radio frequency parameter that is showing. First one is the serving plus neighbor. In this window, you can see here the cell name, eruption, absolute radio frequency channel number. That is the second one is the base station identification code. This one is the basic, that is the identifier of the cell of GSM, right? Basically consists of NCC plus BCC. First digit that is here is showing is 6 is the NCC, network color code, and second digit that is 0 is showing the base color code, right? And third one is the RX level, what the power received by UE, downlink power received by UE, that is the in dBm, minus 53 dBm. And other parameter is also there that is not showing here, C1, C2, that is the cell selection criteria and cell reselection criteria. Next window is important window for GSM radio parameter, radio optimization, network optimization, that is the RX level, right? RX quality, frame erasure rate, bit error rate, FER actual, speech quality index, C by I watched, AMR, C by I, MS power control, MS power control level, discontinuous transmission, timing advance. These are the some parameter actually. Radio link timeout counter, right? Current and maximum and MS behavior modified. These are the some parameters. In radio, we will discuss some of the main parameters, right? The two value is there, full and sub. The full value actually measured for the when DTX discontinuous transmission is off. When discontinuous transmission is on, we only see or observe only the sub measurement, not full measurement. When DTX is on, we will see only the sub measurement. And this one is the current channel. What is the current time slot or frequency on which your mobile phone is connected? That is the cell name, time, cell global identity, all right? Cell GPRS support, yes or no. What is band? GSM, whether it is a GSM 900 or 1800 supported. What is the BCCH eruption? What is the TCH eruption? There are two types of TRX in GSM network. First one is the BCCH, other one is the traffic channel TCH eruption. Basic, what is the mode, whether it is a idle or dedicated mode. Then time slot, right? Channel type, different channel type is there. TCH full rate, fetch full rate, SAG full rate. Okay, so these are the some hopping, whether it is a hopping channel. Hopping means your traffic channel is always on the hopping channel TCH TRX. BCCH TRX is always on fixed frequency. But your TCH TRX is on hopping parameter. There are different hopping frequency. The two parameters there, HSN or MIO, by which our carrier frequency of the TCH TRX is changed. Or we can say TCH eruption is changing after every frame by using this two parameter, MIO and HSN. Frequency hopping, we can see here the what is the frequency hopping actually. Your TCH eruption, sending the signal burst after each and every frame, their frequency is changing. Their frequency is changing by using which parameter? HSN and MIO. HSN is an algorithm and MIO is an offset. That offset used within the MA list. Within the TCH eruption list is there. That is known as MA. Within that list, all the frame by frame, their frequency is changing. TCH eruption frequency is changing. Never BCCH eruption frequency is not changing. Only the TCH eruption is hopping mode and its frequency is changing after every frame, depending on the HSN and MIO and the MA list. That is just a brief introduction of how the TCH eruption frequency is changing after every frame. That is known as the frequency hopping. Timing advance, another one parameter I have seen the window, timing advance signal from MS1 like that. It takes longer to arrive at the BTS than that from the MS2, right? Two MS is there, MS1 and MS2, and base station is there. The time slot overlap or collision. Why they are collide? If they are sending at the same time. The timing advance signal actually causes the mobile further from the base station to transmit earlier. This compensates for extra propagation delay. That's why the timing advance used in the mobile network. The timing advance is calculated from the delay of the data bits in the SS bus. SS bus is the RACH bus, random access channel bus, received by the base station, and long guard period allow the space for this delay. Timing advance signal is always transmitted on the SACH as a number between 0 and 63 in units of bit periods. The TA value allow for round trip from MS to BTS and back to MS. Each step in the timing advance value corresponds to the MS to BTS distance of 550 meter. The maximum MS to BTS distance allowed by the timing advance is 35 kilometer. Because if you multiply 550 into 64, it will comes 35 kilometer. Then serving plus neighbors. Here you can see the cell name of the describe the neighboring cell as per the cell file, what we have loaded actually on the map. Then ARFCN, channel number mobile receives as a neighbor frequency number, basic of the neighbor cells, RX level, receive level in the DPM of the neighboring cells. Okay, first cell is the serving cell and all other the neighbor cells parameter is there, ARFCN, basic, RX level, C1, C2, these are the cell path loss criteria and cell reselection criteria. C31 and C32 actually used for the GPRS signal strength threshold criteria. C31 and GPRS cell ranking criteria is the C32, valid both in the packet and packet idle as well as dedicated. The two value is there na, in the window of RX level and RX quality, right? When we are using when we are taking the measurement of when using full measurement result, when we are using the sub measurement result. So whenever we want to see the BTS parameter setting works at the live network, that is the DTX is off. Whenever we want to see the BTS works without parameter DTX on, that is we are using the sub measurement. When the DTX is on, we are using the sub measurement. When it is a full, that is the DTX is off. So temps measures the full or sub both there, na? The temps record both sub and full measurement at the same time and at the same log files. The log files that we recorded in the laptop during the drive test is recorded both values, sub value and full value. It is just need to set that we want to see the replay mode, right? Which full value you are extracting for the thematic map on the all this for the post processing of the log file. So which value you want to map, full or sub, you can map that one. Next parameter is the RX quality. RX quality values ranging from the 0 to 7. You can see 0 is, it depends on the bit error rate actually. When the bit error rate is less than 0.2%, it is RX quality is equal to 0. When bit error rate is from 0.2% to 0.4%, RX quality is 1. When bit error rate is the between the 0.4 to 0.8%, RX quality will be 2. When bit error rate is 0.8% to 1.6%, RS quality is 3. Likewise, when your bit error rate is more than 12.8%, it is RS quality is 7. It is a worst RS quality actually. 0 is the best RS quality and 7 is the worst RS quality. Next one is the speech quality index. What is the value, suitable value for speech quality index? It is a very good when it will be between 20 and 30. When it is a less than 19 and more than 1, it is a good. When it is a less than 0, it is a very bad speech quality. These are the something used, actually color is used for the thematic map. Which value we are showing green, which value we are showing yellow or white or black, which value we are showing the red. Thank you. These are the some parameters that we are using during the drive test tool, right? Thank you to all.